Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we are identifying a quadratic sequence of numbers. So let's start with something we should already know. I have previously introduced you to linear expressions, quadratic expressions, cubic expressions when we were talking about algebra. I'd like you to pause the video, and for each of all of these expressions on the board here, could you put them under the appropriate titles? Are they either linear expressions, quadratic expressions, or cubic expressions? Pause the video and make sure you sort those out. Well, you should have got the following as your answers. Linear is anything with x to the power of 1 as its highest power, and all of these have x to the power of 1s as their highest power, so they are all what we call linear expression. Quadratics have as their highest power x squared, x to the power of 2, and all of these have as their highest power x squared. If you expand this out, you get x squared add 7x add 10. If you expand this out, you get x squared add 5x. So they do have an x squared in it after you multiply the brackets. And the last column are cubics because their highest power is x cubed. They have a power of x to the 3. All of these are cubics. You may think to yourself, how is this last one a cubic? Well, just think, if you expand this out here, you're going to get something with x squared in it, and when you subsequently multiply it by the bracket x add 5, you're going to get some x cubed involved there. The highest power x cubed, therefore it's a cubic. So we all know about linear, quadratic and cubic expressions. We are now in this video going to try and identify a quadratic sequence. Let's have a look at what those are. In order to think about those, let's just think about the nth term of the following sequence. Pause the video and see if you can remember how to work the nth term out of something like that. Well, the first thing you would have done is you would have looked at things and you would have said, right, they're going up by 3 each time. To get from one to the other, I add 3. What times tables do I know goes up in 3? The 3 times tables. So above it, you'd write the 3 times tables, 3, 6, 9, 12, 15, and the nth term of the 3 times table is 3n. Now our sequence is always one more than the 3 times table, so its nth term is 3n add 1. And the way we'd write it, we'd say the nth term, tn, is given by the formula 3n add 1, and you should be familiar with that. Now let's have a look at another sequence, see if you could do the same thing there. Pause the video, have a go. So, are they going up by a common difference? Well, the difference between there and there is 9. The difference between here and here is 15. The difference between here and here is 21. The difference between here and here is actually equal to 27. What's going on there? They don't have a common difference. Also, they don't have a common ratio. There's no number that you can multiply by to get from one to the other all the time. But wait a minute, let's have a look at this. The common difference between the differences here is 6. The common difference between the first differences is 6 again. And the common difference between these differences is 6 again. So, although they don't have a common first difference, as it did in this linear sequence, they seem to have a common, what we call, second difference here. So when we work out the differences and then work out the differences of those differences, we're getting the answer 6 every time. And that's going to be something really important. So let's go and do 3 examples here to show us the 3 different cases we may encounter. In this first case, this is one we've seen before. They're going up by 3 each time. They've got a common first difference equal 3. This one here, well, we've just encountered this one. This one has gone up 9. This one subsequent to that has gone up 15. This has gone up 21. This has gone up 27. They weren't common, but the second differences were. They were going up by 6 each time. So they had a common second difference of 6. Let's see what's happening in this case. If I do 25 subtract 4, I get myself 21. There's a difference there. The difference between these two here, if I do 82 subtract 25, I get myself 57 in this case. If I do 193 subtract 82, I get a difference here of 111. And in this case here, if I do 376 subtract 193, I get 183. Okay, let's try the second differences. 57 subtract 21, well, that's 36. 111 subtract 57, that's 54. And 183 subtract 111 is 72. Okay, even here the second difference isn't common. But if I do the third difference out of interest, 54 subtract 36 is going to equal 18. And oh look, 72 subtract 54 is also 18. And this has got a third difference that is fixed, and the third difference here is 18. Let's try and see what this means. I'm going to show you the nth term for each of these sequences. The nth term here is 3n add 1. The nth term here is 3n squared add 1. The nth term here is 3n cubed add 1. Can you see how that links to the common differences? Well, when the first difference was the same, we had n to the power of 1 for the nth term. When the second difference was common, I had an n squared, a quadratic sequence, and when the third difference was common, I had a cubic sequence. And that always tends to be our rule. If your first differences are common, you have a linear sequence. If your second differences are common, you have a quadratic sequence. If your third difference is common, you have a cubic sequence. And this can be summarized here, something we should write down and learn. And that's how we're going to identify whether a sequence is linear, quadratic, cubic, or other. If the third difference isn't, if the first difference, second difference, or third difference is not constant, then it's neither linear, quadratic, or cubic. So let's have a go at thinking about which sequences are which. Pause the video. By considering first, second, and third differences where appropriate, determine whether the following sequence is linear, quadratic, cubic, or neither. Have a go. Okay, we're going to do this by common differences. The difference here, the first lot of differences, I'm going to write first here, is 7. This one here is 11. This one here is going to be 15. And this one here is going to equal 55 subtract 36, which is 19. So the first difference isn't common. So let's move on to the second difference. That is 4. That is 4. That is 4. Second difference is common. Therefore, this sign means therefore, it's a quadratic sequence. And we're done. Let's try another one. Pause the video, have a go. Okay, we're going to consider common differences here. The difference here, 6 subtract 8, negative 2. This is negative 2. This is negative 2. This is negative 2. The first difference was common. And in the case where the first difference is common, you can say, therefore, it's a linear sequence. Okay, next one. Pause the video, have a go. Well, the difference here is going to be 9. The difference there is going to be 21. The difference here is going to be equal to 39. And the difference here, 135 subtract 72, is going to be 63. The first difference is certainly not common, so therefore it's not linear. Let's go for the second difference, see if we get any luck there. 21 subtract 9 is 12. 39 subtract 21 is 18. And 63 subtract 39 is 24. Second difference not common. It's certainly not a quadratic. Let's go for that third difference and see if we get any more luck. Well, that's 6 and that's 6. So the third difference is common. Therefore, we can state it is a cubic sequence. Okay? Last one. Pause the video, have a go. Now this one here, the difference here is 2, the difference here is 4, the difference here is 8, the difference here is 16. That's the first difference. Let's go for second difference, see if there's any luck. The difference here is 2, the difference here is 4, the difference here is 8. Let's go for third difference, see if there's any luck. The difference here is 2, the difference here is 4. It's neither a linear, therefore, a quadratic, or a cubic, so we can state neither is our answer in this case. But if we did look at it, and you remember your prior learning, this is actually what we call a geometric sequence. It's going up by multiplying by 2 each time. So it's certainly not an arithmetic sequence, as those have common differences. This has what we call a common ratio. So the answer is still neither, and you could have put in brackets, actually, it's a geometric sequence. which we have done in other sequences. So check out that section of Hegarty Maths. And that's it for this particular video. Thanks loads for watching.